Okay, hello guys. Today we are talking about the arc length. Okay, so let's move to the first part about the arc length formula. Okay, so here we can just say like the arc length can be considered as a part of the circle, right? So we can just consider like this is a sector and here's the arc length. So consider this angle as theta. So we can say that here theta over 360 degree means that a partial right here in the circle, and then times 2 pi radius. Okay, theta over 360 degree times 2 pi radius, and then you can find that the arc length can be also considered as theta over 2 pi times 2 pi r, right? So you can find here, you have divided by 2 pi at the same time. So that is theta times radius. So here we can say the theta is a radians, but not a degree, okay? This is very important. So for example, like here, if the radius is like theta is 1 and s is radius, so just use the formulas that you can say radius times theta and then equals to like 2, oh sorry, here is the s and it equals to the r if theta equals to 1, right? And r theta equals to the arc length and it equals to 2r when theta equals to 2, right? That is how we can understand it for here. Okay. And also we can just find the perimeter of a sector. Like here, if there's a sector and we can set like this is radius and this is arc length r theta, right? So the total perimeter is 2 radius plus r theta, okay? That is the perimeter right here, okay? And also here's a working example for you. Like the sector has a radius 8 centimeter and the angle of 0.6 radians, and find the arc length. So you can just calculate here is a radius 8 centimeter, and this is for 0.6, and just you can use in 0.6 times 8, that here is for 4.8, right? So we can say the arc length is for 4.8 centimeter, and the perimeter of the sector you can use in 4.8 plus the 2 times the radius, that is 4.8 plus 16 equals to 20.8 centimeter, right? That is for the perimeter of a sector, okay? That is for this. Okay, so let's move into an exercise together. Like the first problem is find the arc length if r radius equals to 5 centimeter and the theta equals to pi over 3, right? So you can say here that is radius equals to 5 centimeter, and here is where the angle theta is equals to pi over 3, right? So we can set the arc length here equals to r theta, right? That is for 5 centimeter, then times for pi over 3, okay? So it can be considered as the 5 over 3 pi, okay? And the second problem, a sector has perimeter 20 centimeter and the radius 6 centimeter, and find the angle theta in radius. So first we have to remember that here is for perimeter, right? So radius here is for 6 centimeter, and the arc length can be using 20 minus 2 times 6, right? So we still have 8 centimeter left. So 8 centimeter means the arc length. So we can say here the radius times the theta equals to the arc length. So it's for 6 times theta equals to 8. So theta equals to 8 over 6, or it can also be considered as 4 over 3, okay? So we can say here theta equals to 4 over 3 radians using this method, okay? So that's how we can consider in this problem. So see you next time. Bye.